Welcome back to Have Fun and Learn with KP Datta. Today we will learn a very hugely important theorem which will help us in finding out the area of parallelograms, then triangles, trapezium, rhombus, all will become piece of cake if we understand and if this theorem percolates to your head. Correct? So the theorem statement is on the screen. Pause and copy it. Now explaining the theorem. The theorem says if you have two parallel lines and within these two parallel lines you've got two parallelograms and they share the same base, then the area of these two parallelograms will be equal. Right? Now before going into it, we got to understand three things. What are they? Number one, what is meant by the base of a parallelogram? Number two, what is meant by altitude height of a parallelogram? And next means meaning of two figures lying between the same parallel lines having the same base. So to explain this, we need some figures. Let us get those figures. See, A, B, C, D is a parallelogram, and this is M and this is N. Right? If you talk about the parallelogram of the base being AB, if AB, figure 1, figure 1. If AB is the base of the parallelogram ABCD, then DM is the corresponding height. Height, correct? Now, this is number one. Number two, if you consider BC to be base, if BC is the base of the parallelogram ABCD, then the corresponding height is dm. Then corresponding height is dl. That's how it goes. Right? That's how it goes. Now talking about figure 2. See, these two lines are parallel. So AB, CB, and this is Q, and this is T, and this is R. So parallelogram ABCD, figure 2. ABCD and triangle AQB lies within the same parallel lines. They are AB and CD. And has the same base. We later on see that this triangle will have half the area of the parallelogram, but this blue is not accepted, right? Between means not somewhere in the region of the parallelogram, correct? Understood? Okay. Now we go on to prove the theorem that I gave you on the screen, and let us go into it. And by the way, those who are new to this channel, Have Fun and Learn with JP Datta, you are welcome, and you have become one of our fraternity of students. And please subscribe, view, comment, and share my video. Right? It's important that you subscribe the video, so when you need it, you can get it in one shot. Otherwise, you have to search for it. Okay. So we move on to the proof, right? Let's come back to what we started with, that to prove that the area of two parallelograms, when they are between the same straight lines and sharing the same base, have equal areas. Now see, to solve this, we need a definite strategy. See what we have. We got two triangles, FAD, and a second triangle EBC, and a trapezium DABE. So the best idea will be to prove these two triangles to be congruent and then add this area to each of the triangles to get the area of the parallelogram. So let's do it. The strategy, right? What will be the strategy? Number one, we will prove triangle FAFD and triangle BCE to be congruent. Right? Now the moment you prove them to be congruent, their areas are equal. Therefore, area triangle AFD is equal to area triangle BCE. Right? Okay. Now number 3 will be add the common area to the respective triangles to the area of the parallelogram. So this we are studying. In triangle AFD and triangle BCE, number 1. See, this angle is equal to this angle. Why? I'll tell you. Angle AFT is equal to angle BEC. Okay, why? The reason. Because FE is parallel to AB and EB is the transversal. Correct? Therefore, they are corresponding angles. Now, if you have problems with corresponding angles, alternate angles, interior angles, then you can have a look at the description box. We have number of videos, which will help you in understanding the theory of parallel lines and transversals, correct? Now, number 2. Now see, this angle will be equal to this angle, right? So, angle ADF is equal to angle BCE. Again, you want reasons, right? Reason is DC is parallel to AB and BC is the transversal. Therefore, they are corresponding angles. Correct? Number 3. See, ABEF is a parallelogram. Therefore, AF is equal to BE. Because ABEF is a parallelogram. Right? Therefore, we can write triangle AFT is congruent to triangle BEC. Let's take it as to AF is equal to B, then FD is equal to EC, and then angle F is equal to angle E. So this is correct, right? Therefore, area triangle AFD is equal to area triangle BEC. Correct? Now what we do, is number 1, area triangle AFT plus area ABED is equal to area parallelogram ABEF. Right? Number 2, area triangle BAC plus area ABED is equal to area of parallelogram ABCD. Now, since we have proved that these two to be equal, now we can write area parallelogram ABCD is equal to area parallelogram ABEF. That is what we were trying to prove. This is what we are trying to prove. Correct? Now, this particular theoretical part will immensely help us in understanding how to find out the areas of a triangle that is half base into height, then area of a parallelogram that is base into height, and also that of trapezium and rhombus. Today we will also see how to prove that the area of a parallelogram is given by base into height using this particular theorem. Correct? Now, with the help of the previous theorem, we'll prove the area of parallelogram ABCD is AB into BM, or base multiplied by height. Right? So how do we do it? Before we do that, we need to make a construction like this. See, construction. Number 1, extend CD to L. Number 2, draw AL perpendicular to DC. Right? Number 3, drop a perpendicular from P on DC at M. Okay. Now, as we have already proved that, we know that rectangle is also a parallelogram. Rectangle is also a parallelogram. We have discussed this in previous classes in special types of parallelograms. If you want, you can have a look at the description box and the videos will be there. You can have a look at it, things will become easier. Now, for those who are new to this channel, you are with HaveFun&Learn with JB Datta, and welcome back to our new fraternity of students. And please subscribe to my channel, and share, comment on my videos. Okay, now let's get back to our topic. Now see, using the previous theorem, we say that area parallelogram ABCD is equal to area rectangle ABEF ml. The reason they lie between the same parallel lines, and here's the same base, right? Correct. Now if you agree to that, then area of rectangle ABML is equal to AB into AB into AL, right? That is base multiplied by height or altitude. Therefore, area parallelogram ABCD is equal to base into height, that is base into h. So this was much easier using the previous theorem, right? So that's all for today. And we pick up things next class, and we will take up trapezium, we'll take up triangle, we'll take up rhombuses also. So till next class, have a nice day and ciao.